Unit 10, Section 2, Energy Converters in Mechanical Systems.
Zodiacs are in position. Anytime you feel it's good, go ahead.
Sometimes the amount of energy available is in limited supply. But with an efficient energy converter like the Gossamer Albatross, you can go a long way. In this case, all the way across the English Channel. The Gossamer Albatross accomplished this feat by converting the mechanical energy provided by human muscle into fluid energy of moving air. A mechanical energy converter takes mechanical energy on the input side and converts it into one of the other three forms of energy: fluid, electrical, or thermal energy on the output side. For technicians, the energy on both the input and the output sides have to be measured. The units depend on the type of energy. For example, on this hydraulic pump, the input energy provided by a rotating shaft is measured in foot-pounds or joules of torque, while the output fluid energy is also measured in foot-pounds or joules. An engine is an energy converter itself, but it also has several other smaller converters attached to it. Mechanic Eric Iverson will point them out for us.
In this car, there are four systems of energy to be considered: the mechanical energy, fluid energy, electrical energy, and the thermal energy. The car converts mechanical energy through the belts to the alternator and produces electricity. It converts mechanical energy into fluid energy in the water pump and the fan by either pulling air through the radiator or the water pump pumping water through the engine to cool the engine. The engine converts mechanical energy into thermal energy in the air conditioning compressor by compressing and evaporating the freon, and thus cooling the car. In any type of energy conversion system like this with pulleys and belts, there's a certain amount of loss due to friction and slippage in the belts.
Measuring the efficiency of mechanical energy converters means that the energy put out by the device has to be compared or divided by the energy put into it. That means the measurement of two different forms of energy. In the case of the water pump or the fan, the energy in is the foot-pounds of torque provided by the crankshaft of the engine and delivered by the belt. The energy out is the energy of the moving fluid, which can also be measured in foot-pounds or joules. If the output is electrical, like an alternator or generator, that energy can be measured in joules of electrical energy. But wait a minute, there seems to be a bit of a problem here. Joules and foot-pounds are different units. Fortunately, units can be easily converted from one to the other. We have our handy-dandy unit converter here. You have conversion tables in your text. Converting units to the same form is necessary if you want to find efficiency, because you can only divide units that are the same. So in the case of an alternator, the electrical joules can be converted into foot-pounds or vice versa. If the output is thermal, it can be measured in BTUs or calories, which can also be converted to foot-pounds. In any case, an efficient energy converter loses as little energy as possible in the process. The performance of all energy converters will affect the amount of energy they consume. In the case of an engine, the efficiency of all the energy converters attached to it is particularly important because each of them robs the engine of power that would otherwise go to the wheels. The engine suffers some loss of performance, but more importantly, it will be felt at the gas pump. If mechanical energy converters are too inefficient, all your good intentions will never get off the ground.